The first question here, which is question 10, is telling us to say find the zeros of the following polynomial functions, hence sketch a graph indicating the x and y intercepts. So first of all, you need to understand one thing. If you are sketching these polynomial graphs, you have to look at this part here, which is the leading coefficient. The leading coefficient, and it's called the leading coefficient test. So you have to test your polynomial to see how the graph is going to look. Is it going to come out like this? Is it going to come out like that? Is it going to be 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 like that? So that depends on the leading coefficient. So when the leading coefficient is positive, and when you look at the power there is odd, when the power is odd and the leading coefficient is positive, then note to say your graph is going to come out like this. It's going to have a positive gradient, and then let me just do it this way. If the leading coefficient is positive and then you have an odd function, means that you are going to have the graph which is going to start with a positive gradient and it will end with a positive gradient as well. So meaning it's going to be like that. If it's raised to power 3, it's going to come out like this. If it's raised to another power, as long as it's odd, it's going to start like that and still end like that. What is in between here depends on how big the power there is. Same applies, on the other hand, when you have a negative leading coefficient with an odd power, negative leading coefficient with an odd power, then it's going to start with a negative gradient and ends with a negative gradient. What's in between there will be dependent on how big your power is. So since this is raised to power 3, it's going to be just like that. Yeah. So when you have a negative leading coefficient, then the graph that is going to come out to start and end with a negative gradient to start like that and end with that. So when you have a positive leading coefficient and then you have an even power, a power that is divisible by 2, then note to say you have a minimum value, meaning you have something like, if you are dealing with quadratic equation, you would call it a minimum value. So meaning your gradient is going to start like that and it will end like that. And then the opposite is the case when you have negative and then you have an even, you have the negative leading coefficient and then you have an even power. You are going to have a graph which is going to start with that, like that, and then end like that. Yes, so what is going to be here will be dependent on how big your your power is. Yeah. So let's quickly move on to solving the questions. So these are the most important things that you just need to know about sketching graphs. And then apart from that, you also need to know how to find the zeros. So the zeros are also known as the x-intercepts. Zeros are just points where the curve meets the x-axis. So to find the zeros, you are going to equate this whole polynomial to 0. Hence, we are going to have something like this. We're going to have x to the power 3 minus 2x, and then minus, you have 7, wait, okay, you have 7 there, you have 7x, then you have plus 12. So this whole thing is equal to 0. And then from there, what you're going to have is you factorize this in order to start finding the zeros. So how do you now factorize? You first have to use what is called trial error method. So you're going to use trial error method to know which is your factor, to find the first factor there. So when you use trial and error method, you can say, let's try maybe try x is equal to maybe 1. You try 1 there, you try to replace 1 on each and every variable x there. Try to see. So when you place 1 there, you're going to have 1 to the power 3, which is just 1. Then there it's going to be 1 to the power 2, which is 1 times 2 to be like that. And then you say minus 7 plus 12 is equal to, let's try to see if this is going to give us 0. So for it to be called a factor, it has to give us a 0. Yes. So when you add this, is it possible for us to get a 0? Of course not. So we quickly do us this. So we quickly try another number. Let's try to put 3 there. So when you try x is equal to 3, you put 3 there, it's going to give you 27. Put 3 there, 9 times 2, which is 18. So put 3 there, 3 times 7 is going to give you 21. And then you have plus 12. So when you add this, 27 minus 18, that is 9. 9 minus 24, 9 minus 21, you get negative 12 plus 12. This will give us a 0. So meaning our value of x that we need there is just 3. So trial error method, you can try any number. You can start with 1, you try 1, if it fails you try negative 1, if it fails you try 2, if it fails you try negative 2, if it fails you try 3, if it fails you try negative 3. So here 3 has accepted. So now how do we go about this? We now use synthetic division. So we now use synthetic division to divide this. So we're going to have something like this. You have 1 there, you have negative 2, you have negative 7, you have 12 there. And then you put your 3 there. So you bring down this 1 there, it's going to be there. You multiply 3 times 1, you're going to have your 3. When you add the 2 there, you're going to have 1. 3 times 2, you are going to have 3. When you add there, you are going to have negative 4. And then this 3 times negative 4, you are going to get negative 12. When you add this part here, you are going to get a 0. So this tells us to say, since we have gotten the remainder 0 there, it tells us to say 3 is indeed a factor. So what do we do next? We write this expression now in this format. So you bring this 3 to the other side of the equal sign. You are going to have x minus 3. Then you open the brackets there. And then you have this quadratic equation. These are the coefficients of your resulting quadratic equation. So this is what you're going to have there. And then you have minus 4. Okay. So from there, what you're just remaining with is just factorizing this part. Yes, so you just factorize this part. Okay. So how do we do that? So when you try to find the factors and you discover that what you have been given has no factors, you can use the formula method. So when you use the formula method, you are going to have your first value of x is already there, which is x is equal to 3. And then when you use the formula method here, you are going to have another x value which is equal to negative 1 plus the root of 17. You use the formula, the quadratic formula method, and then everything over 2. And then the other value of x that you are going to have here will be x is equal to negative 1 minus 17, or minus the root of 17, sorry. Then everything divided by 2. So from here we have found now the x-intercept, so meaning we are now just remaining to find the y-intercept. So how do we find the y-intercept? We know to say in the y-axis the value of x is 0. So meaning while there is x there, you put 0. So meaning you're just going to remain with 12. So meaning our y-intercept is just going to be y is equal to 12. And then how is our graph going to come out? Since the leading coefficient there is positive and we have an odd power there, so it's going to be something like that. It's going to be something like that. So this is what we expect to have. So let us now go straight into sketching. Okay. So this side we have negative 1 minus the root of 17 over 2, and then this side we have negative 1 plus the root of 17 over 2. Then finally there you have your 3. So we know that the graph is supposed to come out like this. So this part where it cuts the y-axis, this is where we have our y-intercept, which is 12. So this is where we have our y-intercept, which is 12. So this is how you sketch the graph. The graphs are very simple when it comes to sketching them. So let's quickly move on. Let's pick another question, which is having maybe a negative, which is having a negative leading coefficient. So I'll pick the second question again. So once I solve these two, it means that you can solve the remaining ones. I'm going to help you maybe in finding the factors for the remaining questions so that it can be easier for you to solve. Okay, so let us solve the second question. So the second question has a negative leading coefficient, so meaning it's going to start like that and end like that. Since it's the power 3, meaning it's going to start like that and it's going to be like that. And then from there, let's also use trial error method to find the value of x. So on question 2, the value of x, after using trial error method, the value of x is negative 3. You can try to put negative 3 there, you discover that it's going to give you a 0. So yeah, so basically this is what you do. Then you factorize now. You factorize. Let's use synthetic division to factorize. So we put our negative 3 there, and then our negative 1 there, then you have negative 3, then you have 5 there, and then finally you have 15. Then you bring down this negative 1, you multiply negative 3 times negative 1, you have 3. So when you add the 2, you are getting a 0, and then you multiply negative 3 times 0, you get a 0. When you add the 2 there, 0 plus 5, you are getting 5. negative 3 times negative 3 times 5, you're getting negative 15. When you add them, you're getting the remainder 0 there, which implies that what we have found is correct. So let us now quickly factorize. Let's find the zeros, the other two zeros. So we have our first zero, which is x plus 3. You just take this negative 3 to the other side of the equal sign, meaning you have x plus 3. And then apart from that, you get this quadratic equation that is there. So you have negative x squared, and then you have plus 5. Okay, you have plus 5. And then, so from there, you factorize this. So when you factorize this, you are going to have something like, okay, let me just do this. So you are going to have your first 0 there. When you equate these things to 0, you equate them to 0 in order to find the x-intercepts. So you are going to have your first value of x there to be negative 3. Then when you equate this part to 0, you are going to have the second value of x there to be plus or minus the square root of 5. So from there, you have now your x-intercept. So now how do you find the y-intercept? So finding the y-intercept is also very simple. Finding the y-intercept, you just know, because you know to say in the y-axis the value of x is equal to 0. So meaning while there is x there, you're going to put 0. So when you put 0 while there is x in this expression, you're just going to remain with 15 there. So meaning the y-intercept is just 15. After finding the y-intercept, okay, after finding the y-intercept, remember what we said? We said our estimated curve is supposed to come out like that. Why? Because the leading coefficient there is negative and we have an odd power there. So let us now try to sketch our curve. So we are going to have your negative 3 there, and then you have negative root 5, and then you have your root of 5 there. Then you write your 0 there. Then from there, what you do is you can sketch. You're going to have something like that. So after doing that, what follows now is for you to write your what's this? This one is okay. This one, sorry. Let me just draw this back. Okay. So we said this one is supposed to come out like that. So it's supposed to come out like this. We're supposed to draw it this way. Okay. Then there, that's where you write your 15, because that's why it's cutting the y-axis. Yeah. So basically, this is how you solve such questions. Yeah, and I think I'll be cutting these videos in according to the questions, so that it is easier for you to be revising. I wanted to be making maybe one continuous tutorial, but I think I'll just be cutting these questions. So I'm ending here for question 10. Let me also do question 11 and 13, and I'll send them to you. So this is basically how you sketch your curves. It's not difficult. So try to sketch these remaining curves. Yeah, so if you can manage to sketch them, you can send them to me. I'll just check whether you are correct or wrong. If you have made a mistake somewhere, I'll control you, so feel free to sketch them and send them to me. Okay.